The moon is falling, slowly, silently, and absolutely terrifyingly. You might think, okay, maybe just some crazy tides? Nope, you're about to see one of the worst-case scenarios in planetary physics. The moon has a mass of 81 quintillion kilograms. That's 81 trillion kilograms, or about a billion Everests stacked in orbit. Normally, the moon stays in a stable orbit, 384,400 kilometers away. But if something hit it just right, that orbit collapses. Say hello to Plan A. Smash a massive asteroid into the moon. It's crude, chaotic, and surprisingly effective. As the moon gets closer, gravity stops being polite. Mountains stretch, oceans try to leave, and skyscrapers start leaning. Tidal forces scale exponentially. Every kilometer the moon drops, the oceans climb. At impact, the moon will be traveling 36,000 kilometers per hour. That's 30 times faster than a bullet, and a lot harder to dodge. The energy released? Around 1.4 times 10 to the power of 29 joules. That's more than a billion tsar bombas, the kind of energy that deletes continents. The crust melts. The atmosphere ignites. Earth turns into a magma marble in about 42 seconds. The shockwave doesn't just hit one spot. It wraps around the Earth multiple times. Every volcano on Earth goes off simultaneously, because why not? The atmosphere, blown away, literally. Air molecules reach escape velocity. Hope you weren't using those. Chunks of both the Earth and the moon are now in orbit. And some are leaving the solar system entirely. What's left behind? A glowing, airless rock with no ocean and a molten smile. To be fair, not many things release more energy than the moon hitting Earth. Except maybe another Earth. But it won't happen. The moon is stable, safe, predictable. Unless Earth fell into the moon. Just kidding, sort of. The lesson here: orbits are fragile, and moon-related destruction is creative. That's it for today's orbital nightmare. If you like this cosmic chaos, hit subscribe. We've got black holes next. Technically, other moons could do this too. But only one orbits Earth. For now, tides normally happen because of the moon. But if the moon gets too close, the tides happen to the moon. Let's address the cheese theory. If the moon were cheese, Earth would still explode. Ancient cultures feared eclipses. Turns out, fearing the moon wasn't completely irrational. Should the moon have rights? Maybe, but not the right to kill us. We spent decades landing on the moon. Now it's landing on us. Astronauts love the moon. But even they would probably say, not like this. Can you insure against lunar collision? Number: not unless you own a backup planet. If Earth is vaporized, could we move to Mars? Technically, yes. Practically, no. Final thought: don't punch the moon. Or if you do, wear a helmet. In some alternate universe, this has already happened. Which is why we stay in this one. Aliens watching from afar probably called it early. Oh no, they're orbiting wrong again. If the moon could apologize, it probably would. But gravity doesn't care about feelings. Maybe the moon just needs therapy. Somebody needs to talk about those tidal issues. Imagine aliens cataloging our species like a zoo. Extinct, got hit by own moon. This message was brought to you by physics. Because gravity doesn't mess around. Luckily, the moon is still up there. And we're still down here. Let's keep it that way. But if the moon can fall, what about the sun? In conclusion, don't try this at home, especially if you live on Earth. This was What If the Moon Fell to Earth? Next, black holes, spaghetti, and worse. What if one of the stars you see tonight is actually a black hole heading straight for us? And what if you fell into it? At first, it's just a perfect sphere of darkness. But space itself bends around it. Gravity starts pulling harder on your feet than your head. Until you're a noodle. From far away, you look frozen in time. But for you, seconds pass normally. You've reached the event horizon, the ultimate border. Not even light can escape from here. Inside, there's no up or down, and the laws of physics start to melt. As you fall deeper, space and time swap roles. Moving forward feels like moving inwards. Some physicists think you might enter a wormhole, an exit somewhere else in the universe, or even in another one. But Hawking radiation means black holes evaporate very, very slowly. For a black hole the mass of our sun, that takes 10 to the 67th years. And if you survived that long, the universe around you would be gone. So what's at the center? We don't know yet. But if you ever get the chance to fall in, I'd recommend not. Near the event horizon, time for you runs normally. But for the universe, you're moving slower and slower. From far away, your light shifts to deep red until it vanishes. Inside, gravity is so strong, not even atoms stay together. The energy density here could forge particles never seen before. But where does all this information go? Some think it's stored on the event horizon itself. Others think it escapes slowly through Hawking radiation. In either case, it's one of the deepest mysteries in physics. We may not be able to visit a black hole, but understanding them might unlock the secrets of the universe.